Lagrange to do this question. We're being asked to find the maximum, I should say, absolute maximum, absolute minimum of this function subject to the constraint that 4x squared plus 4y squared equals 8. So basically, it might be only one answer. It might be the maximum. It might be the minimum. In many cases, it's both. We're trying to find what's the biggest product of an x and y coordinate here. What's that guy going to be? If 4x squared plus y squared has to equal 8. And that's kind of a classic Lagrange method, also called Lagrange multipliers. So, solution. Lagrange figured out that all you need to do is solve that equation, which is the gradient of f is lambda the gradient of g. And in this case, the gradient of f is the partial derivative with respect to x, partial derivative with respect to y. Oops. I'm not going to write this line in typically because it takes up too much room and time. And I slow down. If you do a partial derivative of this function, f, with respect to x, you get y, and with respect to y, you get x. If you take this guy here, is who we consider to be g of x. If you do its partial derivative with x and its partial derivative with y, you get that. So our job is to solve this subject to that constraint. So when we're finished, there's going to be 3 equations. If I match this with this, I get my first equation. It says y has to be 8 lambda x. Second equation, x has to be 2 lambda y. And the third equation is your constraint. In this case, that guy. So far, so good. Are we comfortable about the setup? So that whole process here, you might say, was step 1, right? If you want to give it a label. Right, now we try and solve this problem. It boils into 2 different, excuse me. I'm switching off my phone because it's making an annoying beep all the time. Okay, back to what I was doing. You've got this fella here. First thing you do is you look at lambda being 0 and check if that gives you any solution, right? Anything that may or may not work. So in this world, if lambda was 0 and you use it in equation 1, doesn't that basically tell you that y has to be 0? Okay. Now, if you go down to the constraint, when y equals 0, 4x squared plus y squared equals 8. That makes 4x squared has to be 8. That makes x squared has to be 2, which means that there are 2 choices. So I'm going to keep a little hit list over here of places I need to look. So root 2, 0, negative root 2, 0. Okay, that works. If you make lambda equals 0 and you put it into equation 2, then you get x equals 0. And then if you plug that into the constraint, you'll be able to find out what the y values have to be when x is 0. And in this case, y has to be 8. So that generates a plus or minus root 8, which I could simplify if you feel like it to that. Which means I now have 2 more guys. in my hit list, I have a 2 root 2, 0, and negative 2 root 2, 0.
Could we also write the other one as x equals plus or minus square root of 2?
Oh God, I would, yeah. I mean, just to save right. That makes sense? Yeah.
Wouldn't the second set of numbers need the 0 in front to show that the second number was a y number?
Agreed. Right. Anybody who knows me knows that I get distracted really easily, and that blinking phone is still in the back of my head, irritating the heck out of me. And the minute that happens, be on the lookout for quite a few mistakes in the next 5 minutes until my brain settles. So, are we good with the 4 that we found? Right. You know, in a lot of cases, you make lambda equals 0 and it doesn't generate an answer. Can you see in this case, lambda equals 0 actually generated a whole bunch of answers. So be careful on not missing that line out, right? In many cases, it doesn't generate anything useful. Now, that's that bit over with. I'm now going to look at these equations. And I'm just going to write them again for my own benefit. Well, in particular, these two. Because what I'm now going to do is divide 1 by 2. So if you take equation 1 and you divide it by equation 2, this little algebra trick has one job, and it does it really well. Doesn't take it rid of the lambdas. And we can assume in this second part that lambda is not 0. And the reason we can assume that it's not 0 is we've already checked what you would have got if it had been 0. So we're saying, I'm going to divide these two, but I'm not going to let lambda be 0, right? Lambda is some other number, but not 0. And that kind of covers our butt. Now, if you cancel and simplify, again, be on the lookout for me screwing up. Would you agree you get that? And if you do a little cross multiply, you now have a relationship with the x's and y's. In this particular situation, won't y squared be 4x squared, right? Now, how do I use that? I use it in my constraint. Because now I can say that if y squared is 4x squared, then isn't this guy, it can be replaced by 4x squared, which means that we now have x could be plus or minus 1, agreed? Now, if x equals 1, won't y, well, let's do it in stages, won't y squared be 4? So won't that make y plus or minus 2? So that means I have x is 1, 2, and x is 1, negative 2. And if x equals negative 1, won't y squared be 4? And so won't that get me plus or minus 2 again? Which means I now have negative 1 and 2, and finally negative 1 and negative 2. Technically, there are 2, 4, 6, 8 different possible answers to the absolute max and min of this guy. For every single one of these combinations, don't we basically now find the value of xy? And whatever of these 8 is the biggest is the absolute maximum value that that function xy will be, and whatever is the smallest. Now I'm going to try this in my head. Here goes. Won't that guy get you 0? That guy xy gets you 0. Won't xy get you 0? Won't xy get you 0? Won't xy get you 2, negative 2? Won't xy get you negative 2 and 2? Phew. As I scan through the list, is it the smallest number I get, negative 2? So the absolute minimum value is negative 2. And that's all that goes in your homework, -2. And would you agree that the maximum value is 2? So when you go and you type in your answers, it's just minimum value -2, maximum value 2. Can you see why I need to see working in an exam? Because you could just randomly guess between 1 and 10 and got lucky, or you could use some really sophisticated software and cheat. And if I don't see working, then that's what I'm going to assume that you did.
By the way,
Yes.
so our exam's asynchronous, like it's a assignment that we're gonna do.
Your exam is going to take place in WebAssign during a specific time period, just like if you were on ground. So your exam will be a WebAssign assignment. It'll just look like homework. The difference is that you'll be showing me working, which you don't show me for homework. I don't need to see it in that situation. And at the end, we'll try and explain how you're going to show me your working, right? Because that's a big part of what I need to see.
So
Are we comfortable? Yes, question.
can we use this method to like answer the questions on like 14.7? Because when I tried doing like the 14.7 method, I just couldn't figure it out. But this makes a lot more sense.
Yes is the short answer. You're just given the question. Your choice is how you solve it. Would you agree that, like, I personally agree with you, would you agree Lagrange might not be intuitive, but it's pretty straightforward?
Yeah, exactly. That's what I was going to say.
Now, you don't need to agree with me. If you're going to get one of these kinds of questions in the test, right? At least one. So you might decide to use Lagrange, or you might decide to use the more algebraic version from the previous section. Both are correct. I mean, they will get you the same answer. One of them's more intuitive, and the other is easier to do, I think. Okay, so let's do a Lagrange question. Try to find one. Okay, which one shall I pick? Right, I'm just going to do another basic algebra one, then I'm going to do a Lagrange shortest distance to the plane kind of question, you know, something like the ones you got from the previous section. So this one here is at least like question 8, homework. So we have a function, that's this guy, and the constraint is that guy. So delta F is going to be lambda delta G. If we differentiate this fella with respect to x, you'll get e to the negative xy. What else will you get when you do a partial derivative of this expression here with respect to x?
Negative y.
Agreed. Would you agree by symmetry I can just do this for the other one? I don't even think about it. Right, it's going to be lambda. It looks like it's going to be 2x and 8y. Would you agree? Right, now we set up the equations. They're going to be a negative y, e to the negative xy is 2 lambda x. And then the second equation is going to look very similar. It's going to be that guy, except it's going to be 8 lambda y. And the constraint is our third and last equation. And you might say, why is that equal to 1 and less than or equal to 1? Well, technically, we're going to do the lambda 0 one, and that'll take care of everything inside the circle. And it's a little bit easier to check when it's equal to as well. So lambda equals 0 is our first go-to guy, and let's see if that generates anything. If lambda was 0, then won't this be 0? And doesn't that mean y has to be 0? Great. So if lambda is 0 and you use it in 1, you get that y equals 0. And if you go to the constraint, this thing here, won't that generate an x is plus or minus 1? So that gives me plus or minus 1, 0. There's two places I could look. If I use it in equation 2, doesn't it basically tell us that then x would have to be 0? And if x is 0, I believe eventually, can you trust me that y ends up being plus or minus a half? You know, if you make x 0, y is a quarter, y squared is a quarter, so plus or minus a half. So that's going to get me 0 plus or minus a half. And that's us basically taking care of everybody inside the circle or the ellipse. So now we can go back to these three equations. And I am going to do the classic 1 divided by 2. And the top guy looks like this. And the bottom guy looks like this. And we got some extra here. You notice that dies as well? That was good. And some good stuff over here, and the negatives cancel. So the left-hand side just ends up being that. And lambdas cancel, that partially cancels, and I believe I get x over 4y. Do we agree on that? And if I do a little cross multiply, blah, blah, blah stuff, won't 4y squared equals x squared? You agreed? And if I use that in this equation here, then won't that basically transfer to an x squared? Which makes x squared would have to be, or sorry, 2x squared would be 1. So that would make x squared would have to be a half, which means x is going to be plus 1 over root 2, and x could be negative 1 over root 2. Now for each of these choices, we treat them separately and we find out what the y values would be using the constraint, right? Basically using this guy here. Okay. So let's suppose I made x equal that, then won't x squared be a half? I'm trying to cut out some lines here. That makes 4y squared a half, which makes y squared an eighth, which makes y plus or minus 1 over root 8. And can you trust me if you do this one, it's plus or minus that guy. Which means we get 1 over root 2 plus or minus 1 over root 8 and negative 1 over root 2 plus or minus 1 over root 8. So there's 2, 4, 6, 8 places, right? 2 coordinates, 2 choices, 2, 2, 8 places. You then go back to this fella, and whatever one gives you the biggest answer is your absolute max, and whatever one gives you the smallest answer is your absolute min. This will take a fair amount of time, so I'm just going to randomly pick some. So let's suppose I choose to look at this one and maybe this one. Right, just as an example. Right, 1, 0.
We can't see it. We can't see it.
Oh,
The bottom of the page.
there we go. Right. If I check against 1, 0, won't this be e to the power of 0? And e to the power of 0 gets me 1. If I plug this fella in, it's going to be e to the negative 1 over root 2 times 1 over root 8, which is e to the positive 1 over root 16, which is e to the 1/4. Now, I don't know what the other 6 are, or whatever I said they're going to be 12 are, but won't the biggest, let's pretend that 1 was the biggest answer I got, no matter what one I picked, then the absolute value will be 1. And let's say that this guy here ends up being the smallest number, actually. this is bigger than that. So this is the biggest answer and that would be the smallest. So you basically check against all of these. Now, working for a test, I do not need to see you do 10 of these or 12 of these, right? I just need you to do whatever it is you need to do in the calculator and, you know, tell me biggest, smallest. I don't need too many specifics. Are we comfortable with the method that was used to solve this question using Lagrange multipliers?
I am comfortable with the method. I'm just curious. If
Yes.
you have two answers of the same amount, do you report both or just the
Oh,
amount?
well, the question is what's the absolute maximum? So if they're both 10, you just write 10. So you don't need to tell the 4 different places where it's 10. You just need to say 10. That makes sense?
Thank you.
Right. So the WebAssign only wants to know the absolute max and min value, not necessarily the 2 or 3 places where it happens. It cuts down your workload a little bit. Okay, so what I want to do next is, well, time. Let's do an example of a optimization using Lagrange. So this is me doing question 10, or at least a version of 10. We have a plane, that's this guy, and we're trying to find closest point to 0, 5, and 2. Now the start of this is going to be exactly what we would have done in the previous question. Don't we find an optimization function? And for the closest point, is the optimization function the square of the distance? So that's going to be x take away 5 squared plus 0 plus y take away 5 squared plus z take away 2 squared. And since I made a kind of mess there, there we go. And this guy here, I'm now going to write as a 3-dimensional function. And this is where the change happens. If you were doing it in the previous question, wouldn't you rearrange this to say z was equal to, in terms of x, plug it into here and get some pretty messy looking xy equation? But Lagrange can work with more than 2 variables. It can work actually with an unlimited number. We just adapt. According to Lagrange then, this fella should equal that guy. This fella here is actually your constraint function. So this fella, this guy here, is the F, and this guy is the G. You might have thought it was the other way around, but it's not. That's the order. Right, so this fella here gets you 2x. This fella here gets you 2y take away 5s. And this fella here gets you 2 lots of z take away 2. And I'm going to put in a lambda. And I'm going to have to do a g. And the g ends up being, 1, -2, 3. So far, so good? Right, so what do we have? We have 2x equals lambda. 2y take away 10 equals -2 lambda. And 2z take away 4 equals 3 lambda. And I have a constraint function, which is that. Okay. Now, there is two different approaches to solving this problem. In this particular case, one way to solve this problem is to find out what x is in terms of lambda, what y is in terms of lambda, what z is in terms of lambda, plug those in there, find out what the only value of lambda that works is, and once you know that value of lambda, you plug it in here and you solve for x, you solve for y, and you solve for z. It's kind of long-winded, but it'll work, right? It'll work. You want to see that method? Because yeah, I'll show you it then. Okay, if you rearrange this guy, doesn't it make lambda is a half x? Agreed? If you rearrange this guy, isn't lambda -2 that, so negative y plus 5. And if you rearrange this one, isn't lambda 2/3 z take away 4/3? So do you see, lambda is equal to different things depending on which equation that you use. Now the constraint function says this take away 2 of them plus 3 of them must be 6.
Wait, for the first one, why is lambda equal to 2x?
I have no idea.
Yeah.
It's 2. Thank you for catching that. Right, so if lambda is equal to 2x, then let's pretend I didn't do that last 2 seconds. I think the phone is still bugging me. I am going to solve this equation, but I approached it the wrong blinking way, and that threw me. So here we go again. I'm going to solve for x. X is a half lambda. I'm going to solve for y. Y will eventually be negative lambda plus 5. I'm going to solve for z. Z is going to be 3/2 lambda add 2. Well, we assume that I've done this correctly, because I hope I have. And do you know how to get from here to here? You add 4 and divide everybody by 2. You add 10 and divide everybody by 2. And here you just divide everybody by 2. Now, these guys go in here. So x is now 1/2 lambda. Take away 2 lots of y, which is this guy. Plus, I'm beginning to get a little bit annoyed at the result. That's a half. That's 2 lambdas. That's minus 10. That's 9/2 lambda. And that's 6, and it's equal to 6. I'm beginning to regret going this road. 13/2 lambda. What'd you get? 6.5. That leaves 3.5, so minus 7/2. I am definitely regretting this. Add 7, it's add 12, you get 19/2. And ... I'm not going any further with that one. In a few seconds from now, wouldn't I be able to tell you what lambda is? It's a blinking horrible fraction. But once I know what lambda is, won't x be a half of that? Won't y be whatever this is? And won't z be that? And we've got our guy. Right. I'm going to show you how, now that I've seen how bad that is, I'm going to show you how I would have tackled that question differently. So here is this fella. Here is this guy. And here is the constraint. So here are our 4 equations. Okay, do you recognize this trick? Now, if you take equation 1 and divide it by equation 2, you get this fella is equal to this fella. If you cancel this side, basically, what do you get? You get -1/2. If you want, you get that guy. Yeah, 2 ways of doing this. I'll write it this way. Cross multiply. You get that. And a little rearranging.
Why did you get rid of the 2 near the 2x?
Why did I get rid of the
If you
2?
were just canceling out the 2's, you'd also have y minus 5 on the bottom.
Oh, here. Thank you.
You could also simplify that. Just
Yeah.
x over y minus 5.
Yeah. Agreed. And if you rearrange that, won't y be 2x plus 5? Now, if you take
Wouldn't that be -4x equals 2y minus 10 if you cross multiply?
the 2 cross multiply, going this way, yes, and I fix it here.
Oh, okay.
Right. Now, if you take equation 1 now and divide it by equation 3, you get 2x over 2z take away 4 is lambda over 3 lambda. Let's do that cancel top and bottom by 2. Cross multiply. And won't you get z equals 3x plus 2? Okay, now I'm going to use these two in the constraint function. So x take away 2y plus 3z has to equal 6. Well, x take away 2 lots of this guy plus 3 lots of this guy have to equal 6. You see what I've essentially done is I've taken the constraint function and reduced it to one variable. So hopefully we get that. This, and this, and this get me 6x. This guy and this guy gets me, crossover, I believe gets me 10. That makes x 10 divided by 6. That makes x 5/3. Hey, we're almost done. The x coordinate of the point that's closest to the surface has to be 5/3. Won't the y coordinate be 2 times x add 5? So it's 2 of these add 5. 10/3 add 5. 10 add 15, 25/3. Won't the z be 3x add 2? 3 of these, 15/3, add another 6, I believe gets you 21/3. And that guy is the coordinates of the point that's closest to our surface.
Am I thinking about this wrong? But that would be 3 times 5/3. So that should just give you 5 and then plus 2, so 7.
No, you probably are counting it wrong, counting it right. Oh, guess what 21/3 is? It's 7.
7.
So I did it right. I just converted them into thirds and didn't simplify.
It makes you look smarter to have a bigger fraction.
Does it? Bigger numbers look smarter.
On the left page, When you
Yep.
move 2y to the other side, you didn't subtract it.
Yeah, I think it would be negative 2x plus 5.
Oh,
But we got it.
we got it.
With the
Well, you
idea.
just, yeah, follow the methods and just don't make silly mistakes. Right. I have noticed that I'm trying to cover too much, and when I cover too much, I end up just making it less efficient, not more efficient. Okay, we have time now to look at a optimization question involving 3 variables. Essentially the last hurrah. So suppose you have a function f x, y, z, and it's x, y squared z, and it's subject to the constraint that x squared plus y squared plus z squared equals 4. Now I am going to just stick to the 1 divided by 2 trick, right? So we're not going to go anywhere messy. So delta f is going to be lambda delta g. With respect to x, you get this guy. With respect to y, you get this guy. And with respect to z, you get this guy. That looks good. This fella here is a little bit more obviously g. That's the constraint function. So it's partial derivative with x, with y, with z, and a lambda stuck in front of it. I'll pause. Are things looking good right now? Right, so see what happens if I just take a few extra seconds. Now, if you match them up, the first one says that. You match up the second set, if you match up the third set, and the constraint function generates that. So we are being asked to find the absolute max, absolute min, right, of this function subject to that constraint. Okay. Technically, shouldn't I do lambda being 0? Right. Lambda being 0 is a bit messy, because if you make it 0, won't y squared z be 0? This is equation 1 we're talking about. And for y squared z to be 0, doesn't that mean y equals 0 or z equals 0? Or both of them could be 0, agreed? If I plug it into the second one, don't we get 2x, y, z equals 0? And in this world, won't that happen when x is 0, when y is 0, and when z is 0? And if I plug it into the third one, I really just get x, y, and z. So when we're looking at these questions here, aren't we essentially looking at if lambda equals 0, at least one or more of those variables needs to be 0 at the same time? Okay. So let's look at the possibilities or the permutations. If all 3 of them was 0, wouldn't it fail the constraint function? Because 0 squared plus 0 squared, right? So that one into my list. Right, it's not usable. Suppose I make the x and y 0. Then if you plug x is 0 and y is 0 here, do you see that you get 2 choices for z? Does that make sense? If x is 0 and y is 0, won't the constraint say that z squared needs to be equal to 4? That makes z equals to plus or minus 2. Are we comfortable with that assumption? Because some of you are pausing and thinking, and it's got me worried. Right. Can I just cheat here and tell you by symmetry? That's the other combinations. So lambda equals 0 has generated a whole bunch of answers, right? The good news is that isn't every single one of them won't the value of x, y, z be 0? So it's not going to be hard to check them. I know where they are. They're all 0. That might be one of my solutions. I don't know yet. Now, if you take equation 1 and divide it by equation 2, checking my phone here, this will have to be my last question for today. You've got x squared z on the top, you have 2xyz on the bottom, you've got 2 lambda x on the top, 2 lambda y on the bottom. The z's cancel out, one of the y's cancel out, so this becomes y over 2x. The lambdas and the 2's cancel, so this becomes x over y. That gets me y equals 2x squared. Okay? We cool with that, guy? Now, if you take 1 and divide it by 3, so the top one divided by 3, what do we get? We get y squared z over xy squared, 2 lambda x over 2 lambda y. The y squares cancel on the left, and that cancels on
Shouldn't
z. Yeah. And that guy gets me what? X squared equals z squared. Agreed? Now, if you take the constraint function that says x squared plus y squared plus z squared must equal 4, you can replace the y squared with 2x squared, and you can replace the z squared with an x squared. You get that. Well, that makes 4x squared equals 4, which tells me plus or minus 1. So x could be 1, x could be negative 1. If x is 1, won't z squared be 1? So that makes z plus or minus 1. And if you plug negative 1, z equals being plus or minus 1. If you plug x equals 1 in here, y squared becomes 2. So what you get here is plus or minus root 2. And what you get here is plus or minus root 2. So I'm going to try and summarize what's happening here. Don't you basically get any combination you like of 1, 1, and root 2? Now, for every single one of those combinations, you evaluate this guy. And I believe the biggest answer you get is root 2, and the smallest answer you're rounding up with is negative root 2. And that would be you finished. Will you take attendance and say hi right now? I guess I'll keep that there for a minute. Right, let's talk about your test. Does anybody know when the test is?
Isn't it Monday?
9
Yep.
to 11.
9 till 11. So what's going to happen is that it's on WebAssign, and it will become live at 9 a.m. So if you go to WebAssign at 1 minute to 9, you won't see it. If you update your browser at 1 minute past 9, it'll appear. And it's got 2 main features. First feature is you do it on WebAssign, right? It'll just look like homework it'll just have the same, well, WebAssign designs them, right? So it's got the same questions, and you do them, and you write the answer into the boxes. But the second feature is much more important. I need to see your working. So you're going to be actually writing down the working that you do, the stuff, to get that equation. So I'm not just looking for you to have 2 in the first box and minus root 2 in the second box, and that's great. Because you could simply just go to, I don't know, Mathematica or something, cheat, and just write down what it tells you. So I need to see the working, or I'm not going to consider that you did it properly. Now, to do that working, you're going to have to use a piece of software that's called Adobe Scan, but there are other ways to do it. You could just use your printer and scan it to a PDF. Adobe Scan will do it to a PDF. If you've done anything where you had to take a picture of your work and send it to your professor, then you know how to do that. I'm making up a video right now. We used to use Cam Scanner, but they only gave you it free for 6 months. Now I'm using Adobe Scan because it gives you it free for all the time, but it's pretty much the same method.
I use
You're gonna
something
take all
called
your-
Office Lens.
Is that another one that does it?
Yeah, you can make it upload PDF directly to your school OneDrive.
There you go. So you go figure. I just gave you one option. One lens.
Do we turn in the work in WebAssign, or do you want us to like email
Oh
you?
no,
in
you don't
Canvas?
turn it in a WebAssign. What you do is you make a PDF of it. That's why we're talking about these softwares, and you upload it into Canvas. And there'll be a link on Canvas that'll say something like "Upload your working to test 1 here." And what you'll do
Okay.
is you'll click on that, and it'll give you a little hit. I'm making a video right now of it. So if you look sometime, probably sometime on Saturday, because I have a whole load of classes to teach right now, you can go looking and you can watch the videos that I'm making showing you how to do this. And at the same time, that will be there. So when your test is finished, whenever you finish your test, hopefully before the end, you will, you got about half an hour from the time the test finishes to get this uploaded for me. Take pictures or whatever way you do it, upload it to Canvas, and you're done.
Professor, is the test supposed to last 2 hours?
Yes.
It
Unless you get
conflicts with
extensions,
classes.
in which case there will be a extended version for people who get time added.
It conflicts with a class that I have.
Okay, we can arrange that by starting at a different time so it'll end at the right time for you. I think we may have to talk about that privately, and we'll figure something out. Okay?
I don't think
I
it's
also
one
have a
hour.
class.
Oh, are you saying it's a big interruption to everybody?
Yeah, a lot of people.
Yeah, I have a
to
class
his at
immediately
9.
after.
Okay, what about immediately before? I can shift it an hour either side easily. Is that going to interfere with your classes now?
Yes, there's one
think-
before this too.
I think most of us have classes from 9 to 12.
Okay,
Yeah.
so plan B. Well, I'm glad you told me. Let's
I
start
say we
at 1.
take it at 4 a.m.
No, let's not go that way. That would be painful. At 1 p.m. Is that 1 to 3? Is that going to hit anybody?
No.
Anybody
If-
got a problem
if
with
it's
1
Monday,
to
then
3?
that
Hold on, let me check. Let me check my work schedule
Okay.
because I'm not sure.
Oh, I have an appointment that time. Damn it.
Look,
there any way
I'm
you
not
can
going
give
to.
us a Is there any way you
Maybe-
can give us a 2-hour limit and just so we can take it whenever we're free and then
The
upload?
reason I don't want to do that is to reduce cheating. Not that I would ever accuse you of cheating, but if we have the time in different places, George did it early, and then he talks to Peter, and Peter gets an advantage.
I'm looking at my work schedule and I can only do like the original schedule, like what was it, 10 to 11 or I'm sorry, 9 to
10.
11.
Yeah.
That's what I can do.
Sorry, Chief, that won't work.
Okay, let's
Maybe
look
just have us send you emails with the times we had something so you can look at it.
right. I'm
Or
trying to
make
think.
it 1 hour.
You wouldn't want it to be 1 hour, and I know that you probably would think so, but 1 hour means I half the questions, which means if you get one wrong, it's twice as much damage. I could make it 1 hour. That sounds to me like a easier solution.
Please.
Okay, you're getting 1 hour. That's a doable thing. It means that you're going to have to be really, really careful that you do a good job with the fewer questions that you're going to have to do. Essentially, probably 1 from each section. That's all you'll have time for. Yeah, that sounds like a better deal. On the day of the final, we are going to have to figure this out. On the finals exam, there are time slots for us. So the finals, this won't clash. But if this is what it's going to be like, it's going to be 1 hour tests for every single one of your tests then. Because it's going to be the same clash every time, right? Every Monday is going to be the same clash. So be careful about that. So look up the software, look up the videos. It'll tell you how to upload Adobe Scanner, if that's the one you're going to use. And there'll be another video on how that you upload it into Canvas in case you've never uploaded a PDF into Canvas.
So it'll be 10 to 11, 1 hour.
It'll be our normal class time. So we start at 10, we finish at 11. Yeah. So it'll be a 10 to 11 window. There will be a Zoom meeting at the same time. So I want to see you so I can make sure that you've not got your big brother next to you telling you how to do it, or your little sister, whatever it might be. So that will be on. Also, if you get stuck or something doesn't make sense, you can just say, hey, question 4, it's stupid. The numbers don't work or whatever. And I can have a look, and if it is, I'll fix it, right? I will have to adjust the test, not just half it. I think I'm going to have to pull the questions, which just means I basically give everybody a different version of the same question. That'll take time, but I can do it.
How many do you think there will be?
Off the top of my head, is there 5 sections in the chapter that we've just finished? So there'll be 5 questions.
Oh.
So you'll get a question on partial. Yeah, you'll get a question on partial derivatives. You'll get a question on the chain rule. You'll get a question on direction derivatives. And you'll get questions on optimization, right? Absolute max and mins and local max and mins, right? So that sounds like 5 questions. So 5 questions it is.
So since we're submitting our work, does that mean we also get partial credit for that?
Yeah, oh God, yes. So it's not just to stop you from cheating. The main benefit to you will be, if you type in 22 and the answer was -22, WebAssign gives you nothing out of 20 points. But I will look at your working and I'll say, darn it, you just screwed up, 18 out of 20, and I give you the partial credit. So rules of the game. If it's physically written down, you can use it. So if it's notes, you're good. You're not allowed to use software except the 3D drawing software if you want to actually have a look at something to tell if it's a saddle point, and that's fine. Calculators are fine. Anything that's physically written is fine. You're not allowed to look at solution manuals now. You're not allowed to go to eTutor and ask them the question.
Is there
I
a
think that's it.
deadline to turn in the work on Canvas?
You have half an hour to do that, but hopefully it doesn't take more. I just did a little dummy run, and it took me about 3 minutes to scan it, and it took me about another 5 minutes to do that. So it took me about 10 minutes. Can you apologize to your next professor and say, I'm late because Professor Robertson gave me a bloody test and I was uploading it, and I will take the flak for you.
Do the problems also have more than one chance, or is it just like you
get one shot. There's only going to be one set of working, right? So you only get one shot. See if you do a question and it doesn't work out, but you know you were doing it right, because you know what I'm like, when you screw up a number, it goes really ugly on you quickly. That will be wrong. And WebAssign will give you, well, it won't even tell you because you only write one answer down, but it will give you 0 out of 20 points. But I will see your working, and if I just see it's a careless mistake, but you've done the process, you'll get the majority of the working, the points. So don't spend time making it pretty, trying to do it, again, because you know that it should be a different looking answer than the one you've got. If you're comfortable that you've been doing the process, you're going to get most of the points, and that would be my advice to you anyway.
I just want to make sure I understand this. We're gonna just email you the.
You're going to upload it into
module
Canvas. You're going to there's going to be a place in Canvas where you will upload your working. And there's going to be a video on Saturday that you'll look, and it'll tell you how to do it if you've never done it before. And there's going to be a second different video showing you how to use Adobe Scan. Right, so hopefully, if you get stuck on anything, I'm in the Zoom lesson. You can always say to me, look, I'm trying to do this and this scan thing's not working or that's not working, and I'll try and help you through it. Whew, okay, well, I'm glad at least I didn't screw up and just give you 2 hours and then who is it anyway? Is it your physics professors you're in
Yeah.
year 11?
Or no, I have engineering right after.
Right.
It's Tunkel.
Yeah. Yeah, I think he wouldn't like half his class not turning up. So, but if you need to be a few minutes late, you blame me, right? So you don't take the flak. I will take it for you, and I will apologize profusely to him. Buy him a beer or something. Well, he probably doesn't drink, does he? Buy him a midget gym or something. Okay, bye-bye, guys.